Most AI agent tutorials online show you how to build generic chatbots that give the same responses to all users. But what if you want your agent to give tailored answers to the person asking the question? When a user asks about their specific order history or a specific customer support ticket, for example. This is where you need a multi-user AI agent architecture, and this is where things can get tricky. The key isn't just building the agent, it's the security. How do you ensure your agent only accesses one user's data and never leaks information to other users? Get this wrong and you've just built a major data breach just waiting to happen. Get it right and you have a powerful self-service agent that customers can trust and that can help reduce cost in your business. Today I'm walking you through how I built a multi-user AI agent in an e-commerce store and the 7 strategies that I used to enforce data isolation and to secure the architecture. I've been deep in the weeds on the security stuff for weeks, so if you're finding value in this level of detail, then please give the video a like, it really helps us out, and subscribe to the channel for more deep AI content like this. Let's do a quick demo of our multi-user AI agent. For this I created a dummy e-commerce store on WooCommerce, and this has various categories and products as you would expect from an e-commerce store. But the actual agent is embedded in the dashboard, so for that I need to log in. So I've created a few test accounts to demonstrate the isolation of data. First up, we'll log in as Frank Grimes. And once the account is authenticated, we're brought to the dashboard, which has the self-service agent embed, as you can see there, and there's a personalized welcome as well. I placed an order on the 28th of July and I haven't received it. Where is it? So this question is going to go to the n8n workflow. It'll hit the AI agent who has a number of tools that it'll be able to use to answer this question. And with the new n8n streaming mode, it's able to stream through a result. So I checked your account. It has found the order. And it's even saying, if you haven't received this package, I can share the proof of delivery image and escalate this to our support team. So I'll ask it to show me the proof of delivery. And as you can see, it was able to provide me a photograph of the delivery itself, which is saved in Supabase storage against that account. So here it's asking, if I don't recognize the delivery, would you like me to escalate it to the support team? So I'll say, yes, please investigate. This isn't my front door. And here we go. It has successfully escalated the investigation. And if I jump into our customer support inbox, you can see that there was a self-service escalation with information about the customer, what the issue is, a priority, conversation history, and even notes, including a link to the proof of delivery in question. So as you can see, this is quite a sophisticated self-service agent. And the key aspect of this is, how was it able to successfully pull this specific customer's details to tailor the responses the way it has done? And to demonstrate this, let me just copy this question out and let's log in a different account. This time we'll log in as Hank Scorpio and let's paste back in this question. I placed an order on the 28th of July. And as you can see, it's streaming through a result where it's checked the account and it doesn't see an order for that specific date. And it says, here are the orders around that date in case the user got confused. Can you provide the invoice for order number 6? And as you can see, it's generating a secure link to this invoice. And if I click on that link, then it loads the invoice from the secure repository. So this is a standard Supabase signed URL, so you can decide what the expiration is of that URL before it becomes invalid. What was the total dollar amount of my orders in the last month? And there's a good clarification question. Do you want to base it off the previous calendar month or the last 30 days? Let's go with July. The AI agent has a calculator tool that it's going to use, as we know that language models don't always get calculations correct. And here's our response. There isn't any orders from July 2025. That's my mistake. If you meant July 2024, then here are the totals. And I've just confirmed that those order totals are correct as well. What items were in my last order? And here we go. The most recent order, number 4, contained this scarf, which again, I've confirmed that was order number 4, which is the scarf at 67.25, which is right. If you're looking to accelerate your AI journey and get access to the workflows and plugins that I demonstrate in this video, then check out the link in the description to our community, the AI Automators. So let's look under the hood to see how this AI agent works. We are using n8n's native chat embed widget. So this requires your standard chat trigger node. And if I click into it, you can see that we have embedded chat mode enabled. It's publicly accessible with basic auth, and I'll get into that in a couple of minutes. We're loading the memory from previous sessions, and we have streaming mode enabled, which is a newer feature and works really well for keeping users engaged. There's a little bit of messing with JWT tokens, which I'll talk through in a few minutes. But the main agent itself is configured to use GPT-5. It has short-term memory using Postgres with Supabase. And then in terms of the tools, It's able to fetch the customer record, fetch orders and order details. It's able to generate signed URLs for those resources like invoices or proof of delivery documents. And it can also escalate the query. I won't dive too much into these tools because in a way, creating the agent is actually the easy piece to this. Securing the agent and ensuring data isolation is actually the tricky bit. So if we look into these tools, let's say fetch customer record, you can see that in the conditions below, we are hard coding the customer ID from what we are receiving from the webhook. And this is crucial because it protects against prompt injection hacks. A malicious user can't try to persuade the AI agent to hand over information from other customers. The application logic here is filtering based off customer ID. And that's the same then for all of the database queries. When it's fetching orders, it's filtered by the customer ID. So for this multi-user AI agent, let's have a quick look at what's in Supabase. So we have a number of tables. We have our customer table, which has our test customers that we logged into the front end with. We have an orders table, which includes order statuses and total amounts, along with tracking numbers and links to the various documents like proof of deliveries and invoices. There's order items, which are linked to the orders. We have our n8n chat histories table, which is what's tied to the memory of the agent. And if we dive into storage, you can see that we have two buckets, PODs and invoices. And inside those buckets, we have folders for the customer IDs. So here's the proof of delivery image that we saw in the AI agent chat. In a previous video on this channel, Alan went over the difference between a multi-instance setup and a multi-tenant setup, where in a multi-instance architecture, each client has an isolated app that can be fully customized. With multi-tenant, all of the clients share the same database, so there's strong data separation logic required. There's also another level to this which I'll be getting into in this video, which is the difference between a multi-tenant setup and a multi-user setup. Both of these share similar characteristics. So for example, in a multi-user setup, you have a web app, or in this case an e-commerce store, and that store or that app has multiple customers or multiple users. Those users are able to log in and access their own private information. So typically in a multi-user setup, it's a single organization, in this case the e-commerce store. In a multi-tenant architecture, you have a single app or a single code base, and instead of individuals having accounts directly with the app, it's organizations that do. So you have multiple organizations, and those in turn would have users that they could manage themselves. But again, all of the data is stored in a single database, again requiring some pretty strict data separation logic to make sure Organization 1 can't see Organization 2's data and vice versa. But that data separation logic is required in the multi-user setup as well. User 2 should not see data from user 1. In this video, I'll be going through examples of a multi-user setup, but the logic is pretty similar to a multi-tenant setup. Instead of a customer ID here, you would have a tenant ID. You just need more complex logic here for the user management and access controls within these tenants. A good example of multi-user is Netflix, where individual users would have accounts on the platform. Whereas Shopify is a good example for multi-tenant, where you have a general Shopify platform and then individual businesses would create online shops and then users would have different user roles and permissions within those stores. This also impacts the n8n license that you would require to actually run this type of system, which I'll get into later in the video. So when it comes to the AI agent here, the possibilities are endless. You could hook up lots of different data sources, different databases. It could be a CRM, it could be carrier tracking, a support desk, essentially whatever you need to offer self-service functionality to an end customer. The key thing is to secure it, which leads me on to 7 strategies to enforce data isolation and secure this type of architecture. So to kick off, let's just look at the standard n8n chat embed that's available for everyone today. This embed is really easy to actually get up and running on a website, and that's essentially what we have here. So on WordPress, I created a new page. I added the embed code, as you can see here. I dropped in the URL of a new workflow I just created, which has a simple chat trigger. I've enabled streaming because it's really cool to see. Embedded chat is the mode selected, and then the agent just simply streams a response. I saved it, and now I can ask a question, hello, and you get a streamed response from the agent. How can I assist you today? And this is effectively what we have here. So this is a standard public chat embed. The code is added to the website backend, but essentially this chatbot renders on the front end. this script that we added actually triggers in the browser of the user on the front end, and it communicates directly then with n8n. And that's totally fine for a public chatbot. It's fast, it bypasses the website backend, and responses are streamed through and you can have your conversation. And if I open up the network tab here and if I ask another question, I'll just say test 1, 2, 3, you can see that this has sent a message to my n8n instance. So I can actually see the URL of this workflow in the browser. And you can see the payload, so it's send message, test 1, 2, 3, and the response is essentially what we got there streamed through. Again, all fine because this is public. But if you want to move this to a private style multi-user chat embed, this is a big problem. And the problem that we have here is that the webhook URL is going to be visible, as well as any authentication that you send through, along with the ID of the customer that you're actually querying. So to demonstrate this, if we come back in here, click on chat message received, let's add just basic authentication. We'll create a new credential. So the user will be authorization and the password 123, let's say, and we'll save. And now if we refresh here and ask a question, test 1, 2, 3, you'll see you'll get error failed to receive the response. And if we open it up here, you'll see that we're getting a 401 error message, which means authorization is required. So okay, let's add the authorization. So you'll see in the documentation, we can add headers to the config. And for this, we'll add in authorization. It's basic auth, and we need to drop in a base 64 encoded string. I'll just do it quickly here. And the format is username : password. So we'll encode that. There's our string. We drop it in there and save. And now let's ask a question. So we'll ask hello. Okay, so it has authenticated. We're getting an answer back. You can see it's a 200, so no longer a 401 authorization required. And we are getting a data response. The problem with this approach is that now if you go to the headers, you can actually see the authorization. So there's basic and there's our base 64 encoded string. And as easily as I created this string, it's as easy to decode it. So if you click on decode here and paste in the string, you're going to get the username and password. So obviously this is not secure. And the other thing is we do need to send customer IDs with these requests because we want to be able to query the orders of a particular customer. So n8n needs to have a customer ID. So again, if we were to come back in here, and let's just add in customer ID is 1001. If we save that and refresh, ask a question, and go to the headers, you can now see customer ID 1001 in the headers. So it just means that anyone is able to change that customer ID in that request. And they will be able to cycle through customer IDs and essentially extract out all of the sensitive information for each of your customers, resulting in a catastrophic data breach. So clearly, having all of this information in the browser is not fit for purpose for a private style chat embed. So okay, how do we get around these three issues? Well, the key is you don't make any of this actually accessible to the front end. So you do that by creating a proxy. So in this scenario, instead of allowing the front end to communicate directly with n8n, the front end can only communicate with the backend, which is the WordPress backend in this case. And that secure backend is the one that then communicates with n8n, and when it receives responses, it streams those to the front end. So with this setup, the front end would never see your n8n webhook URL, it would never have access to that basic auth, it would never be able to see the customer ID in the headers to change it. And because all of this would be over HTTPS, it is end-to-end encrypted, so it's a lot more secure. So to create this type of proxy within WordPress, I created a WordPress plugin called n8n Secure Chat. And essentially what it does is it exposes this proxy endpoint, as you see here. It requires the user to be authenticated to access it. And then when communicating with n8n, it passes the basic auth as well as the JWT token that it creates. It adds a customer ID field to the user profile in WordPress. And this is essentially what ties the logged in user on the front end to the customer IDs in the database. But the key is that this is injected by the proxy and not accepted from the front end. And finally, this shortcode is created so that the chat widget can easily be embedded on any page on the WordPress site. And this is how the plugin renders as a widget in the dashboard. Now, I spent a bit of time styling this so it doesn't look exactly like the n8n one. But if we go to the network tab and ask a follow-up question, instead of hitting the n8n webhook URL directly, it actually now pings the backend of WordPress. So you can see it there, wp-json/n8n chat v1. And it's this backend that actually carries out the processing. And what it does is it looks at the user's logged in session on WordPress. It loads up their profile and extracts their customer ID. And then it sends that customer ID directly to the n8n workflow. The plugin creates an admin page for the secure chat where you can set the basic auth username and password and the JWT secret key. Now this could be changed so that these keys are actually stored as environmental variables on the server and not accessible in the WordPress admin. That again would make things more secure. So this type of proxying solves a lot of the problems that we encountered with the general public embed. But there's one problem still outstanding, which is how can you verify that the request actually came from WordPress in this instance? Because for example, if someone gained access to your WordPress admin and copied out the URL of the webhook and the basic auth information, they would then be able to hit n8n completely in isolation and be able to extract out customer details. So there's a need to verify that the request came from WordPress. Now there's a few ways to do this. You could have an IP restriction here, so you're checking the IP address of the request, and did it come from this fixed IP of the WordPress server? You could set up a site-to-site VPN as another option, and that's something we've done on a previous project with a large client. Or another approach is to set up a JSON web token or a JWT. And that's essentially the approach that I went with here. So I created the code for a JWT that's generated on the WordPress side and is verified on the n8n side. And all of that is managed using a shared secret key between the two systems, as you can see here. So every time someone asks a question to this self-service agent, a unique JSON web token is created and sent to n8n to be verified. And the key thing is, this JSON web token has an expiration, or it has a shelf life. So if we look into the previous execution that I just triggered, and we jump into the chat message trigger, you can see that we have a JWT that has generated, and we now have two additional nodes. So the first one is it verifies the JWT against the shared key. So the credential that it connects to has the secret set, and it's the same secret that's in WordPress. And this essentially generates its own JWT with that key, compares it against the one it received from WordPress, and if it's the same, then it knows that it came from the right origin. The payload itself is only base 64 encrypted, so this isn't used for encryption, it's more used for verification of origin. So here we have now verified it came from the right area, we have decoded it, and we are then able to send it into the agent for a response. And the reason this is needed is that this chat trigger doesn't have a JSON option for authentication. You can only authenticate using basic auth or n8n user auth. The standard n8n webhook does actually have JWT, so you wouldn't need to go to this effort. But you can actually test this out. So I'll click on execute step with that data pinned. And now if I click on verify a JWT, you can see that there's now a problem with it in that the JWT has expired, as you can see on the right-hand side there. So even though this request did come from WordPress, the expiration has passed. It only lives for 60 seconds. So that way you can't have replay attacks where people try to reuse JWT tokens that have been intercepted or possibly fished out from server logs, for example. So we are in good shape here. We have the n8n chat embed rendering from a secure backend. In this case, it's WordPress. And by virtue of doing that, we're hiding the webhook URL of n8n. We're hiding the basic auth information. The customer data is hidden, so it can't be changed to actually extract out other customers' sensitive financial records. And we have a JWT to verify the origin of the request. A critical security change we now need to make is actually on the Supabase side. So n8n is connected to Supabase to retrieve customer records, order details, etc. And even though authentication is handled in WordPress and not in Supabase, we still need to enable row-level security on all of the Supabase tables and the storage buckets. And the reason for this is, if I just disable RLS on the orders table for the moment, so I'll just click disable RLS and confirm. Now I have an unrestricted pop-up. Data is publicly accessible via API as RLS is disabled. The reason for that is this is sitting in the public schema. So if I now go to Postman, and if I trigger a call to this table, to this endpoint, I'm getting all of the orders in the database, as you can see there. And all I've done is I've passed just the anonymous API key. And it's called anonymous for a reason. It's for the general public. So this key isn't actually private. Anyone can find it and use it. And that's by design. It's supposed to be a public key. So this is a major problem, and you will receive lots of emails from Supabase if you have tables or buckets that do not have RLS enabled. So I'll just turn that back on again, enable RLS for this table. And even though we have row level security enabled, and we don't actually have any policies against these tables, as you can see, there's no policies on any of the tables, this architecture will still work. And the reason for that is the default way that n8n integrates with Supabase is by using the service role key, which bypasses RLS. Now that raises a different issue that we're going to get into further in the video when we talk about the principle of least privilege. But at the very least, you definitely need to enable RLS on all of your tables, all of your buckets in Supabase if you want them to actually be private. And with RLS re-enabled now on that orders table, if I send the same service call to that orders table, you're now getting 0 results back. So this architecture is becoming more secure. However, there are still a number of holes to be plugged. Of course, one of them being WordPress. The admin just logs in with the username and password, so it would make a lot of sense for a multi-factor authentication here. It would make sense for kind of complex password policies, so you can't have test123 as a password. Because once someone is able to log into the WordPress backend, they essentially have access to all of the passwords and secret keys that make this architecture secure. So this brings us on to the fact that while this is generally speaking secure and encrypted end-to-end, if any part of this architecture is compromised, there could be a massive data breach. So if we take WordPress as an example, it's an open source platform. There are lots of community modules that aren't really independently vetted and verified from a code quality perspective. So if you don't keep your WordPress installation up to date and the extensions up to date, or if you write code yourself that has holes in it that attackers could actually find and exploit, then you're leaving the doors wide open for data to be extracted from your systems. And particularly with this architecture, we are using WordPress as our secure auth server. It is the source of trust for users as they're entering usernames and passwords into it. So if you were to imagine a scenario where this application was exploited and compromised fully, then how do you limit the damage? And one way to do that would be to use multi-factor authentication within the actual AI agent chat. So you'll see this type of architecture in a lot of applications where sensitive financial details are actually displayed on page, and it's called step-up authentication. You'll need to provide another level of authentication, usually with something that you have in your possession, such as your phone. So with this architecture, we still use the proxy. The user asks a question of the agent, which is routed through to n8n, but then there's logic within the n8n workflow, which checks to see has the user successfully completed this step-up authentication. And if it hasn't, n8n will then fish the customer's record out of the database. It'll get that user's phone number, for example, and send a one-time SMS code to that user, which would then need to enter that into the AI agent interface. And that could then be verified in n8n, and you know that even though WordPress may be compromised, this is actually the user because the hacker would not have the user's phone, for example. So what this does is it limits the blast radius of a hack. If someone got control over WordPress, they wouldn't be able to cycle through every single customer ID in the database and extract out all of the sensitive information. If it was an active hack, however, they would be able to log the usernames and passwords and one-time codes that are entered here, so they would potentially still be able to access certain customers' information if it was an active exploit that wasn't shut down in time. And this is where monitoring kicks in a lot, because you need to monitor the behavior of these applications and make sure they're operating within standard parameters. A variation on this could be that you have a different web application so that when the user gets the one-time code, they enter the code into the different application, which is then verified in n8n. That way the hacker would not have access to your one-time code. So there's always different design and architectural variations that you can use to secure these apps. So while multi-factor authentication would help to limit the damage done by a compromise of WordPress in this instance, there then remains the question, well, what if n8n is compromised? What if you have a really old version of n8n? Or what if the software on the server has not been kept up to date? And this can actually happen more than you think. Even just 3 days ago, I got an email from n8n saying that they have found a security vulnerability in one of their versions and for us to upgrade our software immediately, which we have done. So it would be very easy for someone to just ignore this email and there's a potential exploit of the software, which may allow privilege escalation within the instance, an admin account takeover, unauthorized access to sensitive information stored in the instance, and by virtue of that, with the credentials and connections set up in the instance, you could get access to sensitive information within backend systems as well. So it is absolutely paramount that you keep your n8n instance up to date and the server software up to date as well to keep the software as secure as possible. And the other important thing is it doesn't need to be a hack of n8n. If you have a really simple password that could be brute forced, or if you maintain bad password practices and it's leaked, if you don't have multi-factor authentication set up on your n8n instance, then someone could gain access to your instance even though it is fully up to date. So the primary knock-on of that is they would gain access to backend systems if you have provided privileged access. So if we take Supabase as an example, typically you allow your service role key to be set within the credential. And that essentially is the God key. It gives access to everything within that Supabase project. And that's generally bad practice. And unfortunately, it's the only way to actually integrate Supabase with n8n using their core modules. So this brings us on to the next point, which is the principle of least privilege. You should only grant the minimum required level of access needed in the backend systems to perform their functions. So in this type of AI agent system, it only ever really needs read access to, let's say, the orders table and the customers table, and it would need write access to the n8n chat histories. So a better approach here, instead of providing the service role key, is instead to create a specific database user with those more isolated, restricted permissions. But even with that type of lockdown database user account, with the compromised n8n instance, it still will be possible for someone to exfiltrate a lot of customer records from your backend systems. So this brings me on to the next technique, which is row-level security within the database. And this is really defense in depth. This is a zero trust architecture where you have two applications that are set up securely, but if they do fail, you are protected. So in this case, our WordPress instance wouldn't use WordPress as the source of trust for authentication. Instead, a secure identity provider is used to authenticate accounts, and it returns a secure access token. So in this case, it's Supabase Auth, but it could be any number of ID providers. So the secure access token is sent back to WordPress, and that access token is passed with each request to the n8n workflow. So if n8n was compromised, the hacker would never have access to anything other than the specific access token of that customer. And even that customer access token is short-lived. So then when n8n makes requests to the Supabase backend, it's passing that access token, and the security is enforced within the database layer. So we have RLS policies that fully control what that user can actually see and do. So I have a version of this up and running for my Insights LM project, which you may have seen on other videos on this channel. So when I log in here to Insights LM, what's happening is I'm logging into a React app that was created on Lovable. The username and password are sent to Supabase's auth to retrieve a secure access token, which then grants me access to the dashboard as you see here. So if I was to look into the network tab of this application, I would find that secure access token. So then when a request is made to this React app, such as, is there any reference to the ERS in this private document that I uploaded, I'm getting a message back based on that access token. So what happened here is that request was sent to a Supabase Edge function, which verifies that the request came from someone authenticated and authorized, which in turn then calls this n8n workflow. So this is the chat flow, and let's load up that execution. And if we look at the webhook, you can see we're getting the message and we're also getting the access token. Now I have made some changes to this flow to lock this down with this access token, because as I mentioned earlier, the standard n8n node only supports having a service role secret as a means to connect. So it only essentially allows for this super admin access, which doesn't follow this kind of policy of least privilege that I talk about. So here, the AI agent is now triggering this retrieve from vector store sub workflow that you see here. It's passing the query and the access token. We're generating an embedding because this is a vector search. And then we hit the Supabase vector store. We're hitting the match documents database function. We're passing our access token as a header, as well as the anon key for the project. We pass the embedding that was created for the query, and we're getting back 10 results, and that's what we do here. So as you can see, there is no authentication set we are only authenticating based off the access token that was sent from the React app in the first place. And this result is 10 documents that's coming from this documents table within this Insights LM project. And as you can see, RLS is enabled and we have 4 different policies. The main one here being users can view documents from their own notebooks. They can't view documents from other people's notebooks. So those documents are then retrieved from Supabase, sent back to n8n, which are in turn sent back to the edge function, which are then sent back to the front end, rendered to the user. So this is the modern way of securing these types of web apps and agent systems. Database enforced security with well-defined application logic in front of it. Now that's not to say that the previous approaches aren't secure. Not all customer systems support this type of identity providers and this type of database row security. Security through application logic was the standard for decades. It's just that by enforcing security at the database level, it provides real defense in depth in case there is a compromise. I've gone through a lot of security techniques in this video, but there's still way more that you can actually do to secure your applications. Where the end user actually interacts with the application on the front end, you could use Cloudflare for anti-bot protection, DDoS protection, and as a general web application firewall. So that definitely would reduce the attack surface for a hacker. Of course, all communications in this architecture should be over HTTPS or TLS. So that way everything is encrypted end to end. It's important that you validate and sanitize any inputs that the users or the admins provide to make sure that there's no SQL injections that could be used to compromise any of the logic within these systems. Rate limiting is another approach to slow down attackers if they did gain access to various different elements of the design. The connection between WordPress and n8n here uses a basic auth key and a JWT secret key. So actually rotating those on a regular basis is also good practice. It's important to have logging and monitoring across the architecture as well. That way you'll be quickly informed if anything unusual is happening and you need to step in. And of course, there's an assumption here that everything is public. This is an externally accessible WordPress server, n8n server, Supabase, but some of this might be in a local network. So that way you can use firewalls and have a DMZ as a buffer in between external traffic and internal traffic. You also need to make sure that the logic within your custom code, in this case it's a WordPress plugin, or in your n8n workflows is actually sound. And there's no bugs or broken logic that may result in an accidental breach of data. On the compliance side, there's a number of considerations if you're building this private style AI agent that would have access to personally identifiable information of your customers. And there's 2 elements to this. The first one is your relationship to your customers. So depending on where you're doing business and what regulatory environment you're under, be it GDPR, CCPA, or something else, you may need explicit consent or explicit opt-in from your customers to have their data processed by AI systems. You definitely would need to update your terms of service and your privacy policies, mentioning the various AI features and how that AI is processing that data. On the relationship that you then have with your LLM provider, you essentially need a data processing agreement which sets out how the LLM provider is going to handle this sensitive customer data. Generally speaking, most of the main providers offer this as standard. So if you're using the OpenAI's APIs, they have a data processing addendum which you agree to just to create the API account in the first place. It's the same with Anthropic, which is attached to their commercial terms of service. If you're in a more restricted regulatory environment, you may already be using Microsoft products. So if you were to use OpenAI via Microsoft Azure, that fits under the standard Microsoft data protection addendum, which you may have already agreed to. But essentially what you're looking to confirm is that there is a zero data retention policy with these LLMs. So they're not storing your customer data even for logging, and definitely not storing it for training. You need to make sure that all of this data is wiped after use. The other important thing is data residency, because if you're in the EU, you need to abide by GDPR, which means data can't actually leave the block unless there's data processing agreements in place. If even with these data protection addendums, you don't trust these LLM providers to do right by your customers, then you may need to self-host your LLMs or run them totally locally. That way data never leaves your network. And a way to reduce the compliance burden is actually to anonymize data before it's ever sent to an LLM. So there's lots of different libraries and techniques you can use to detect personally identifiable information within messages. So the example here could be customer John Smith bought an iPhone, which includes his email address. And one of the techniques would tokenize the name and the email address before it's sent to the LLM. And then the tokenization is reversed after it comes back from the LLM. So it's usually not possible to get this 100% accurate, even using the best libraries and models. But it's possible to dramatically reduce the risk if you are worried about some sort of data breach on the LLM provider side. But the important thing is, even with or without data anonymization, you should never really be sending really sensitive information to an LLM. So definitely not payment card information. You probably shouldn't be hosting that in the first place. But any health related information, social security numbers, financial information, IBANs, you should definitely look to avoid sending anything like that. You need really strict controls over that type of information. On the licensing front, n8n has both a sustainable use license and an enterprise license. Generally speaking, what's allowable under the free license is any use that falls under what they deem to be internal business purposes. And what they specifically say in the license is, in practice, all use is allowed unless you are selling a product, service, or module in which the value derives entirely or substantially from n8n functionality. They give examples of what's not allowable under the license, so white labeling or hosting n8n and charging for it, or using users' own credentials to access their data. To be honest, I find the license quite vague. I think it's very difficult to tell what actually falls under the license and what would require an enterprise license. In the use case that I walked through in this video of an e-commerce store which is communicating with its customers via an n8n chat, I really can't actually tell, does this fit under the sustainable use license or the enterprise license? An e-commerce store's customers are not technically internal business users. At the same time, this isn't a SaaS app. Customers aren't paying to access it. It's an existing commercial relationship that an e-commerce store would have with its customers, and the customer service has just been improved using this mechanism. The customer's credentials aren't passing from the front end to the back end because we're using an external auth server, be it WordPress or Supabase. So there's a lot of grayness in this use case. So I reached out a week ago to the n8n licensing team with this email that you see on screen looking for clarification. And unfortunately, I haven't got a response back. If I do get a reply after this video is published, I'll let you know in a pinned comment what the actual decision is. But from my perspective, I'm quite confused as to what actually fits under the sustainable use license versus the enterprise license. They brought out these new commercial plans for self-hosting, where there's now a startup and a business tier, and then you need to contact sales for an enterprise license. So do these two tiers fall under the enterprise license, or do you actually need this one here? I'll leave links for the sustainable use license and the enterprise license in the video description. I hope you found this video helpful. Don't forget to like and subscribe to our channel for more deep AI content like this. Thanks for watching, and I'll see you in the next one.